A5, we are going to discuss on database per service. One of the design. Okay. What is the advantages of the database per design per service? What is the disadvantage? Where it will fit? What type of project it will fit? All these things we are going to cover. You all agree with this?
Okay, so we are going to discuss about the service, or is it kind of for database?
We are going to discuss about the database. We are not going to discuss about the service. See, the services are multiple. If I have, for example, I'll show you. I have a product service here deployed. Okay. Understand? Product service. Okay. And I deployed a I had a payment service, something like this. Payment service. These are all microservices. Okay. Now I had deployed a order service. Now I had deployed a order service. Now tell me, if all the services has the same database, is it a microservice architecture? Come on, guys. Is it a microservice architecture or not?
Yes, it's a microservice architecture.
Single database where you connect everything. This, you will say it is a microservice architecture. Is this a microservice architecture as per your knowledge, what we discussed yesterday?
Yes, we can use this independent databases for each service, or else we can use
no. Don't get into that. Don't get into that. First, we need to understand the drawback of this. And then we can get into that. You tell me, if I want to make an order, let's say an example, user is making an order from the front end. Make an order. First step, what basically the service will do? Check product exists. Am I right?
Yes.
Check product exists. Second point, if product exists, make payment. Am I right? If product exists, make a payment. Third point, payment successful, make an order. Am I right? Payment success, make an order. In this scenario, your product exists is successfully called and it is working fine, and your make payment also made successfully. Unfortunately, order got failed. What will happen? You have to make a rollback or not? You have to refund the money to the user. You have to remove the order weightage into the system because those orders are not sold. Am I right? Business point of view, think as a business point of view, you are making an order from Flipkart or whatever it may be. Program, Praveen. You understand, right? You are making an order. Or you got my point? When you make an order, what will happen? First, you will check for the product exists or not. Second thing is what you will check. If the product exists, you are going to make a payment. When you are making a payment, if it is successful, you are going to create an order for dispatchment. Am I right? Unfortunately, your product is working fine, and then payment is existing fine, but your order creation has not happened. due to certain reasons or technical glitches, whatever it may be. So do you need to roll back, Mahesh?
Yes, we should.
When you are
Yes.
taking a rollback, if you are using a single database, all the schemas are dependent, where you will have primary key, foreign key relationship within the single database, right?
Yes.
Anything goes wrong, or if your payment goes wrong, your entire system will be crashed. Am I right or wrong? Because you are depending on a single database. It is not an independent database. Is it a microservice architecture? It is not a microservice architecture. It is a monolithic architecture still. Even though you have plenty of independent services with having a single database, it is called monolithic database architecture. Clear my point?
Yes.
It is a monolithic database architecture. So that is the reason Microsoft microservices thumb rule is per service independent database. Per service independent database. You should not maintain single database for every services. If you are maintaining that, this will not work fine. Typically you understand the business flow, right?
Yes.
So if you are understanding that business flow, you can't able to provide the proper microservice architecture. You can't able to provide the proper microservice architecture. If you really want to make a proper microservice architecture, every database will be same. Clear my point? Sir, how do I prove that? Now, if you go back, I have a PowerPoint. Let me open a PowerPoint, which will give you the brief introduction of database per service. There you go. Is it okay? Slides?
Yes.
See, the main problem here is shared database anti-pattern. Multiple service accessing the same database. We discussed here. Do we discuss here or not? I have a product service, I have a payment service, I have a order service. All these three services are connected to a single database. So that is the problem. The problem is it is tightly coupled. When there is a table affected in payment, automatically your product service will get failed, even for order service will get failed. Am I right or wrong? Or if you are having a problem with your order table, your entire microservices will get down. Am I right or wrong? Mahesh, Akshay, Mahesh.
Yes, sir.
Understand, right?
Yes, sir. Yeah.
Okay. So that is the problem they are telling. Tightly coupled, hard to scale and deploy. If I want to deploy only a product service, I'm depending on the single database. Or I want to make a change in my product service, do I need to depend on a single database? Hello? Hello? Do I need to depend on a single database or not? So to avoid that, we are going to plan solution is database per service. Each service own its DB, own database. How are we going to do that? Let's do this. A product service as a independent database. A product service as a independent database. A payment service as a independent database. Whereas my order service as a independent database. Tomorrow, if anybody comes want to deploy a product service, they can deploy product database as well as payment database. They are not going to worry about payment service or order service. A product team will deploy only the product database. Here you will have payment service. This is called a typically microservice architecture. Payment DB. Okay, this is your order DB. Order DB. Or you got my point? If anybody want to make a payment, they will have their own individual databases. Is it a best option going with the microservice architecture? So every service should require independent database. Then only we can call this architecture as a microservice architecture, or we can say service oriented architecture. Clear my point? Everybody clear? Rahu, Mahesh?
Yes.
Akshay, Ritika, please unmute.
Yes, sir.
Unmute program. Hey, if you're coming free, please leave. If you really want to attend the session, unmute and talk. Ritika? Okay.
Yes.
And one more thing, no cross DB access. What does it mean? Can I access product service to payment DB? Is it possible? Not possible. Because every independent service should have independent database. Every independent service have independent database. That is the idea behind database per service. Or you got my point? Now coming back, core principles, leave it. This is the architecture overview we discussed. User service will have a user DB. Order service will have a order DB. Product service will have a product DB. Payment service will have a payment DB. So whenever you are making a microservice, every individual microservice will have independent database. You should not go for a single DB connect with the different services. That is not a proper design. Or you got my point? So if anybody asks you an interview question, what is database per service? You need to create individual service with independent database so that it will be more secured and deployable and achievable in a production manner. Clear my point? Agree with this point?
Yes.
Yes,
Okay.
sir.
Fine. Now let's go to the other topic. Real-time flow. User places an order. Whenever user places an order, first what they will do? See, you go to Swiggy, you are placing an order. Okay, let's take an example. You are going to a Swiggy app, you are placing an order. When you place the order, what are all the things will happen in the backend? First, they will check whether the product is available or not. Am I right or wrong?
Right.
Right?
Right.
Okay. So order validate the product. Once order validate the product, what is the next step they will do? Make a payment. Am I right or wrong?
Right.
Once the payment is processed, they will make the confirmation of the order. Am I right or wrong?
Correct.
In this single transaction from an end user standpoint, how many services, independent services we are touching in real time? We are touching first user, whether the user is a valid user database service, and then we are touching the product DB, and then we are touching the payment microservice, and then we are touching the order microservice. So how many services we are connecting at the same point in a single transaction? 4 services we are connecting. First one is user service. Second one is product service. third one is payment service, fourth one is order service. Everything has an independent database. Okay, this is the real-time flow, how the microservice architecture works. Any questions on this? Any questions? Program, Mahesh?
No.
No. Can I move
Clear
forward?
so far.
Come again? Clear?
Clear so far.
Fine. So next thing is, how are we going to connect these microservices independently? Here, if you look into that, I created a product service, I created a payment service, I created an order service. I want to call these services independently. For that, we have three different ways of communication mechanism. One is REST API mechanism. Here you can say, first point is REST API mechanism. Second one is Kafka. Kafka we are not going to use. It's highly impossible to implement in local environment. And third one is event-driven system. Event-driven, with the help of Saga, we can implement. Event-driven system. I will explain event-driven Kafka everything in the next upcoming sessions, but I can implement only REST API and event-driven in our project. Okay. Now, these services will call like this. That is why we are consider this as an API gateway. What gateway? This is your API gateway. This is your API gateway. Whenever you want to invoke a microservice, you require an API gateway. Sir, my question is one more thing. My product service is success. Okay. My payment service is success. Unfortunately, my order got failed. How do I need to roll back? Do I need to roll back? Say yes, sir.
Yes, we need to.
For that, for rollback mechanism, we will use a Saga pattern. I will explain this pattern tomorrow. We will use a Saga pattern or Kafka pattern. Or you got my point? So we are going to discuss Saga pattern and Kafka pattern by tomorrow for rollbacking the microservice architecture. Or you got my point? Don't think about it right now. Whereas in database, if you are writing any query or a single monolithic database, we used to have an ACID mechanism. Am I right or wrong? Do we have an ACID mechanism? Hello? In database, yes, we need to roll back. We use ACID mechanism. Am I right or wrong? This is the mechanism we will use, right? Let example of transactions. We write logic in the transactions where that you will begin roll back, commit. All these things you will implement in database. Similar fashion, same kind of implementation you required in service-oriented architecture, microservice architecture. For that, we are using a pattern called Saga or Kafka. Any questions? Mahesh and Akshay? Raghuram?
So whenever the order is not confirmed, then we can directly use the database queries to make the rollback.
No,
right?
that is not a right approach, right? Because order database will not connect the order microservice will not connect the payment DB, right?
Oh, got it.
See, when order microservice got failed, you need to roll back your payment, you need to roll back your product. Am I right?
Correct.
In that case, your payment DB and product DB are not connected with order microservice, right?
Yes, makes sense.
So in that case, I need to do a rollback mechanism with the help of Saga pattern. Clear my point?
Yeah.
It
So
makes sense.
yes, correct.
Yeah, please go ahead. Ask
You,
questions.
you were mentioned one point regarding the Kafka. So we are not going to implement in our project, or is it not possible to handle in the local host?
It can handle in the local host, but I'm not implementing in the project since I'm going for Saga pattern.
Okay, got it.
Okay.
Yeah.
Okay. Any other questions?
Sir, like,
Yes.
like this API gateway, uh, do we use it to make contact with each individual service or how?
Come again.
That API gateway is there. So
Okay.
also API gateway is used for connecting to each
Yes. Yes. See, API gateway is an intermediate between your UI application and microservices. Got it?
Okay, is it common or independent for each service? That's what he is asking, I
No,
guess.
API gateway is an independent service. It is an
No, no. So
independent
for
service.
individual service, we are going to create a different API gateway, or it is a single
No,
gateway that
within a
going to
single
connect with all.
API, see, within a
Okay.
single API gateway service, we are going to call all the different services. See, let's give an example. User giving an order. What is your request and response? Let me give clarity. I think that is a very good question. See, user makes a request. What are the information you require from user when he make a request? Make a request of order placement. User make a request of order placed. What is the input you are getting from the user? First one is user ID. Second one is order detail. Third one is payment detail. All these are your single response, single request. Am I right or wrong? Everything combined together, we make a request as a single request object. Is it correct?
Yes.
Is it correct or wrong?
Correct.
Now, what I will do, step one, user ID, validate. User ID, validate to user microservice. Am I right or wrong? Whether the user is a valid user or not, you will go and check with the user microservice. Agreed?
Agree.
Okay. And then what is the next step? Check placed order products available in inventory. Where this inventory is available? Product DB or order DB. Inventory available in product microservice. Am I right?
Right.
Makes sense or not? Yes or no?
Yes.
Third point, if products available, what is your next step? Products
Payment.
available. Make a payment using payment microservice. Am I right?
Right.
Fourth point, if payment success, order will be confirmed. Order will be confirmed in order microservice. Order will be confirmed in order microservice. See, all these things, with this orchestration will be developed by API gateway. Clear my point? This will be packed. These steps will be performed by which gateway? API gateway. Now you understand it is also a part of a service, microservice, right? API gateway is also a part, one of the microservice. API gateway is also a one of the microservices. Do you agree?
Yes.
So is it an independent service or it is a part of the UI or different microservices? API gateway.
Independent service.
Independent service. Now you understand, right?
Yes.
Akshay, got the point?
Yes, sir. Yeah.
Clear my point? Fine.
Yes, yeah.
Now let's go here. Now next step is Saga pattern to handle distributed transaction. So where you will implement Saga pattern in API gateway or in individual services? Where you will implement Saga pattern?
I guess in API gateway.
API gateway as well as individual services.
Oh, okay.
Because API gateway need to tell payment service delete the payment. There is event exchange brokering will happen or not?
Will happen.
Come again?
It will happen.
It will happen. So in that case, my subscriber will be your payment service. My consumer will be your API gateway. Understand?
Yes.
So Saga pattern will implement on every individual services based on consumer and subscriber. Clear my point? If
Yes.
consumer saying that, subscriber saying that, my consumer is saying that payment failed, I want to roll back my product. So that immediately consumer will tell the product microservice, can you delete it? Clear my point? This is your positive flow, ma'am. Where you see, user ID is not valid. If user ID is not valid, what will happen? What we need to do?
We are
Send
not
the
able to.
response back to the client.
Okay.
Not a valid user. Am I right?
Yes.
Yes.
Yes or no?
Yes.
Yes.
Now, here, the user ID is valid. So I'm coming to the next point. Here, the negative scenario, no product available. Unfortunately, product has been already sold out. Before he make a request, somebody has make a request and read the product. Now, no product available. What you need to do? API gateway use Saga tell product not available. Am I right or wrong?
Right.
This is your negative scenario. Whereas you come here, product is available, making a payment fail. Making a payment fails. What will happen? API use Saga tell product service delete the product or roll back the product. Service to roll back product DB. This is correct?
Yes, and also we need to send the message as well, I guess.
So that will finally send the message. This orchestration will send a message to the end user. But the orchestration happen like this. For that, we are using this distributed transaction. local transaction per service, compensation of failure. What is compensation of failure? If your order is placed, product available, user ID available, unfortunately payment failed. What do you need to do? What do you need to do?
Roll
You
back
need
the
to
product.
compensate that failure. How you are going to compensate that failure? You will roll back your product and then you will send a message to the user. Am I right or wrong?
Yes.
That is your compensation of failure. Every service has a local transactions. The two transactions are successful. Third transaction got failed. You need to compensate your successful transaction, saying that roll back and send a response back to the client. That is where the saga pattern comes into picture. Clear my point?
Yes, sir.
Akshay,
Yes.
Raghuram, you are in mute.
Yeah.
You understand, right?
Yeah.
No, these types I can explain later point of time. The advantage is independent deployment, scalability, technology freedom, fault isolation. What is independent deployment? Can anyone tell me? By understanding this architecture, what is independent deployment?
So for each service, we are using the independent of databases, so we can directly deploy the independently. For example, for product service, we can once the product DB is ready, then we can deploy the product DB. It's not dependent on the any payment or order DB services.
Okay, that's great. Now you understand, right?
Yes.
Why microservices is most important in real-time industry?
Understood.
You all understand, right? What is the purpose of microservice architecture? Why do we need the microservice architecture to be developed? Am I right?
Right.
Okay. Now coming back, scalability. What is scalability? Let's take an example of order service. There are millions of transactions are coming to the order service. Can I, at a single point of time, 2000 concurrent users are coming to the order service. Can I scale my service into 2-3 different servers by implementing a load balancer?
Yes, we can.
Let's give an example. Can anyone take a screenshot? I'll put it in the group so that everybody can understand. I will explain with the diagram. Taken?
Yeah, take the screenshot, but we are unable to.
You can't able to do
right?
it. Yeah, I understand. Because if I give a request to everyone, then it will be a problem.
Yeah, pasted in the here itself in chat.
No problem. I'm taking 1 second. I think this is done. You see your WhatsApp?
Yes.
Now new. See, I will tell this one, scalability. Let's take an example of order service. Okay. Order service, which is a combination of both DB and the services. Okay. You have a order service. Okay. Now what happened at a single point of time, 100 consecutive calls are making to the order service. How many consecutive calls? 1000 plus consecutive calls. My application is unable to handle a concurrent 1000 calls at the same time. What should I do? Mahesh, what should I do?
Use the load balancers.
No, first I need to
Looking into
scale.
Okay.
I need to scale. How I can scale is I will create a one more image of order service. Clear my point? I create a one more image of order service alone. Order service alone. And this order service will automatically have a load balancer mechanism here. What mechanism? What mechanism here? Come again? Load
balancer.
Whenever 1,000 concurrent users are making a request, this load balancer will give few requests to this service and few requests to this service. This is how scalability will happen. Understand my point?
Yeah.
1,000 plus users. Or you got my point? But your database is one only. Only the services we are making different. The database is one because database can handle multiple transactions at a single time. So database order DB is same. Only your application logic running out of memory so that I am scaling my application. Clear my point? You understand what is scalability, Akshay?
So how we will divide into order services? Can you explain one more time? So is it like deploying two different servers with the same service? Okay.
Yes. Scalability is nothing but deploying the same service with two different servers.
Got it.
Clear my point?
Yeah.
Akshay, understand?
Yes, sir.
So that is the reason we are having. And one more thing, if you are going with database service, technology freedom will be there. One service people can use SQL Server database. Other service they can use MongoDB. Other service they can use PostgreSQL. Other service they can use Redis Cache. They can make a technology freedom that what type of database they want to store the data. Am I right or wrong? If I go with the monolithic architecture, if one database is decided, your product entirely decided on same architecture. Am I right or wrong?
Right.
And one more technology freedom is instead of performing everything in .NET, I can develop few website, few microservices in Java, few microservices in .NET. Can I do that? Order service I'm developing through Java. Other services I'm developing through .NET. Is it a technology freedom why I'm implementing microservice?
Yes.
So these are all the advantages when we go for microservice. Not only for the business standpoint, from the technology standpoint also, microservice giving a vast of expansion in such a way that I can able to decide my database and I can also able to decide my technology that can be used and independent deployment, scalability, everything can be done. Clear my point? No need to develop everything in .NET. No need to develop everything in Java. No need to develop everything in Python. I can expand. Few services may develop in .NET. Few services may develop in Java. Few services may develop in Python. That is the advantage microservice architecture is given. Okay?
Okay.
So this is the main reason people are moving database per service. Challenges. Only thing is data consistency, complex queries, monitoring complexity. All these things will be get rid of with the help of. These are all the challenges we are going to overcome. You want to maintain a consistent data. That is possible. Complex query, you are get rid of it. You are not going to write a complex query. See, if you are having everything in a single database, you will write a store procedure. What are all the terminology? This I told this one. Everything you will write in store prop. Am I right?
Right.
So now I am not writing any complex queries. Am I writing any complex query?
No, we are reducing complexity.
It is a straightforward tables. That's it. Product table will have product service. User table will have user service. Payment table will have payment service. Order table will have order service. Am I right? Independent tables, independent services. Am I right?
Right.
Yes.
So we are not going to write any complex queries here. And complexity also easily monitored. Am I right or wrong? With the help of Saga and Kafka. Am I right? Because this event-driven orchestration will easily tell you where it got failed. Whereas when you write a complex query or a complex project, what will happen? That complexity cannot be maintained. Am I right? Are we going to maintain that complexity?
No.
So that is the main reason we are going for microservice architecture with the database per instance. And next topic is CQRS. I will take tomorrow because we are running out of time. I thought everything can be covered in one day. Not possible. So explain DB per service. Can anyone answer this question? Hello.
Yes, sir. So as we discussed, for service, if we are maintaining individual databases, we are reducing the complexity of the queries to writing, and as well as it's a kind of monolithic kind of pattern we are avoiding. So individual service will have the individual databases, then it should be a good architecture
Okay.
to use.
How to manage transactions between independent?
By using what we call it,
What pattern?
anti-pattern also.
Saga pattern.
Oh, sorry. So is there any other pattern that we have other than this?
Kafka. Kafka.
Only these two are we are using in industry?
Yes, mainly these two.
Okay.
Okay.
Yeah.
What is Saga pattern? How to avoid this pattern? When to avoid this pattern? I'll tell all these things later point of time. Okay. Tomorrow
Okay.
we are going to talk about CQRS pattern, which is most important pattern in microservices. Okay. Let me demonstrate something in the code. Since we have a time, as per our code, what we are developing right now, how are we going to maintain what type of database we are maintaining? Now, if you go back, first my thing is catalog. What database I'm using here? Can anyone tell me? What database I'm using? By seeing this code, what database I'm using?
MongoDB.
Raghuram Mahesh. Huh?
MongoDB.
MongoDB. What is the service name? This is catalog service.
Right.
Now go back. Basket service. In the basket service, what repository I'm using? What is this?
So I think it is very sketchy. Yeah.
Redis cache. So I'm going to store everything in Redis cache. So My catalog service is using a MongoDB. My basket is using a Redis cache. What about my discount service? What DB I am using here?
No, it's PostgreSQL, I guess.
PostgreSQL. Got my point?
Yeah.
So this is how independent services are maintaining independent databases. Now, how are we going to compose in your Docker? This is how we are going to compose. You see here in the Docker compose file, catalog as an image of Mongo, basket as an image of Redis, discount as an image of PostgreSQL. Clear my point?
Clear.
So, independent service, independent data. Clear my point? Yes or no?
Yes.
Akshay, Raghuram. This is the
Yes.
one we are going to build in our next couple of days. Raghuram, you understand?
Yes.
Clear my point? So tomorrow also session is there. We are going to discuss about this area. Command, query, mapper, handler, which is nothing but CQRS pattern. I will explain that tomorrow. Okay? Same time tomorrow we can connect. Okay, let me stop recording. Ask your questions.